samples, and the doctors are annotating that, and diagnosis are made by the doctors that whether some specific disease is there in the blood sample, from the blood sample, it can be inferred or not. So that's the traditional system we have seen for a long time. Almost everyone has experienced. Now, by God grace, his business is going good, and now he is finding it really difficult because the number of blood samples being collected by that diagnostic center is becoming too high, and the doctors who are there in that particular diagnostic center are less compared now. So, with a higher number of inflow of the patients, the doctors available there are unable to cope up with that, and hence your friend asked your help because you are computer scientist, data scientist, you are working in this field. So he asked you, okay, nowadays I'm listening a lot of this term that AI can do this, so can you help me? And then you suggested, why not? Let's make a model. So let us say earlier system, if it is called as diagnostic system, let us call that I can create a diagnostic plus AI system. So I can create a system which may be called as diagnostic plus AI. And here, instead of the doctors going through each and every sample, what we will do is we will collect the sample. The sample will be given to certain models, and then model will mark, or model will give their decision that whether it is having certain sort of say positive certain disease or not. And then doctor can finally rate on that. So they can only just check it, go through it, okay, whatever has been predicted by the model is good enough or not. So in that sense, you can feel that the doctor's workload will be reduced, and probably with 2-3 doctors you have, you can cope up with that. Your friend can go on good with that. So that's what we talk about when we talk about the healthcare applications of diagnostic applications of AI. In fact, one of my scholar has also done some work in that field. So we can take like the CT images, not only blood samples, we can take CT images, X-ray, and then we can go through that X-ray by image processing techniques by using certain CNN or RNN based models, and then they can predict, they can even highlight that these are the area which is having certain abnormality, and then finally a doctor can go through that and rate it, okay, this is good enough or not. If not, then probably they can give their own comments. So that's the system you developed. And while developing, so obviously as an engineer now, that's for the business person. Now as an engineer, if you think how you will do that, so how you will make this diagnostic plus AI, so what you will do as a computer science machine learning engineer, you know that we will collect certain features. This everyone almost knows. Just for completion, I will take a minute on this. So we'll take certain features. So a patient, will give an ID to a patient, and then we will capture some of the say details of that patient along with the blood samples. We'll create a feature vector out of that. So say in our case, the feature vector is n cross n. And then we will also create a label for that for historical data, obviously whatever our doctor has done for years now. So we can take those data and we can create a label for that. And then this data can be given to a model, and that model I am representing here by fxy. So let me just annotate this. So this is where we are capturing. So this is the model we are developing. I will come to that, how that model can be developed. So we have certain features. Features I mean to say the blood samples, the age, sex, then locality, and so on. So other fields, whatever we have developed. So that is the feature. And then we have a target that whether there is any disease predicted or disease existing in that system or not. So, and this fx, this is the model we are developing. So normally this model are represented by fx, sometimes only fx, sometimes a prime x, and so on. So people can use different notations for that. Now, once you develop that model, so while you are going to develop that model, what you do is you take the historical data, you divide that historical data into two parts, training and development set or validation set. So you give that training data to the model trains itself on that particular data, then you can give the validation data set, and it will check that whether on the validation data set, if it's working well or not. If you are satisfied that okay, with the training data set and the validation data set what I have kept aside, if the model is working good, that means your training is now over. Now once the training is over, you say that okay, let us create some test cases. So probably you can parallelly run it for some time where your doctors will be really going through, and then you will have your sample giving to the blood to the models, and the model can give, and then doctors can keep on evaluating for initial some pages. So they will be giving that same attention what they used to give in the manual system. And if you find that for testing case, if it is working well, that means now you are ready to deploy it. So you say that okay, my system is now okay, good enough, and I can deploy it. So deploying means now you have made that system operational. So whenever a new sample, new patient comes, you collect the data of the new patient, you give it to the model gives the prediction. Again, we are keeping the doctor in the loop just to wait it that okay, it's good enough. Now the problem with this system, so this system is now okay, fine, running, good. Now, is there any problem in this system? The question is this: is this system foolproof? Is the system good enough? Can it be deployed, or can it be used in this way in a medical system, medical setting? The answer is probably no right now. Why? The problem is like this. So problem, let us come to the problems one by one. What are the issues in this system? Not problem, in fact, issues we can say. So the first issue we can talk about or we can think is of data leakage. Now what is data leakage? Data leakage refers to some features which are highly correlated with the level. So although whenever we have created that means annotated the data set, created or collected the data set, we have never think of that way. But sometimes it might happen that some features in your data, while it was in training, basically leak. That means it has got a strong association, or basically it predicts that this is going to be yes or no. So other important parts are not being used to assign that particular level. For example, a very popular example is the KDD Cup challenge. Those who works in medical setting, they know the KDD Cup challenge, although the data set is quite old, but still it may be used by people to just validate their result on the legacy system, older systems. So in that KDD Cup challenge, a data set of X-ray images were released, and those X-ray images were of breast cancer cells, and the levels were whether it is benign or malignant. And there was a patient ID, then the X-ray images, and then a level. Now you will be surprised to know that the team who won first in that KDD Cup challenge basically only took care of the patient ID to predict that whether the cell will be, whether the X-ray image will be marked as benign or malignant. Now, all of you, those who are attending here, will be surprised if they are not knowing it earlier if they do not have this information, then this is really a surprising information for all of you. Why? Because you know that patient ID is not a field based on which I can say that whether a X-ray image is benign or malignant. This is never thought to be in that way, but it has happened. That's a reality. Why that happens? And that's called as a leakage. So where this field, patient ID has leaked the labeled information to this particular setting, to this particular model. So model has identified that based on the patient ID, if I assign that whether some patient is having cancer or the cell is benign or malignant, the accuracy was quite high. Why that happened? Because when the data was collected, some hospital, because the data was collected from different hospitals, and some hospitals, while they were giving that patient ID, they had put a field that whether the patient is serious or normal patient. And if the patient is serious, they have marked it. So they have kept that coded information in the present ID field. And that coded information was in fact used by the model to associate or to predict that whether it was benevolent or benevolent. I hope I am clear with this point to everyone. So here the patient ID leaked information about the target value. So that's what we call it as data leakage. So it might happen that whenever you are writing a paper in this field or using certain machine learning model, a lot of time the reviewer gives a comment that have you checked that there is no data leakage and so and so. So they are in fact referring to this sort of problem. So have you checked that your variables, that means all the X fields are not having strong correlation with the Y field. If someone is having a very strong correlation, say if one of the field is strongly correlated to, say for example, if I say that I have got say a field say x1, say x2, and say I have xn field which are supposed to make my prediction y, and it is found that say x2 is highly correlated with y, then it is useless to see into other fields. Only looking at x2 you can predict y, what should be y once I know the x2. And it might happen that x2 is not a very important feature. In fact, that should never be taken care of while you are going to predict y. Am I clear to everyone? If you can say at least give any indication, raise your hand, and so at least I can assume that there are some other party, because really sometimes it's really boring to talk to the monitors. So time to time I will be requesting you to please at least respond or raise your hands or give certain comments in the comment section. I have another window open. So if you are typing anything, any question, I will be able to see that, and in fact I will be able to respond. Include that in my presentation. Okay, so coming to the next problem. The next problem is of bias. So that's the problem of data leakage. The next problem is of bias. Now bias means, in fact bias refers to when a machine learning model makes an unfair prediction based on the person's race, gender, ethnicity, and so on. So say you have developed a healthcare application and you found that that particular healthcare application is taking care of the gender, and based on gender it is assigning certain, it is biased. That means it is giving higher probability of having certain disease or not having certain disease based on the gender or based on the ethnicity. So in that particular case, we say that the model is biased. Biasness is now becoming a big issue, especially some system. If you see, like here I have given an example. I have taken an example from, this is from Amazon face recognition system, face challenges commercial AI system to recognize faces. You see here with a lighter female, it is predicting that as a female, and the probability associated with that is 92.9%. But with a darker female, it is, although it is recognizing it as a female, but the probability, the confidence in that is saying that this is female, the image is of female, that confidence level or the probability value decreases to 68.6%. Whereas in case of male, if you see, whether it is having a darker complexion or lighter complexion, the confidence level is more or less say, around 98 to 100%. That means what? The model has learned that most of the females are fairer. So if there is a dark complexion, that is a female, the model is a bit confused. Model is not very confident. And that's a commercial system. That's a system which is already being used. That's the problem of biasness, or bias in a machine learning model. Now, one of the case study, if you want to see, in fact, this was again implemented, and Compass AI system. This is used by US court to predict future criminals, and it is found that for the same offense, black and white, they are predicted different sort of verdicts. So might be white can be just left or given a small amount of fine, whereas a black person is sentenced say 3 to 4 years of jail and along with a hefty fine. So this has been already seen by the models. So this is again another issue which is very important, and in case of this machine learning or sorry healthcare application or legal system, this has to be taken care of before the machine learning models are really going to be utilized in a real sense. The other application or the other issue, in fact, not application, the other issue is of regulatory compliance, non-compliance. According to the General Data Protection Regulation (GDPR) by European Union, so the European Union in 2016 adopted a set of regulations on how the data should be collected, stored, and processed by foreign companies. And in that article number 22, it gives it gives the power to the individual, or it assigns individuals the capability or right to ask any AI developed system or AI models why this decision was made to them. So then the AI model has to predict why they are predicting like this. So if it is a medical case, why they are saying that I should take this medicine, or I have this disease, on what basis they are coming to this conclusion. So providing an interpretation or explanation for why the algorithm made a particular decision is in fact made compulsorily by this General Data Protection Regulation (GDPR). And you can see the model which we have just developed as Diagnostic Plus AI. This system does not comply with this regulatory compliances. So we need to have something extra into that. The other one is concept drift, although this is very common thing. Why common? Concept drift means, say you collected data today and today you developed a model. So, and if you say you have collected data for something, say for market survey, you have collected data and you developed a model based on that. The model is in operation. Say you think of 5 years ahead. Now, down the line of 5 years, the income level, the education level, the locality status, everything may change. So while things will be changing, so after 5 years, the model may not be making very good prediction. The accuracy of the model will decrease. There will be a dip in the performance of the model. There will be a dip in the performance of the model over time, and this is called as the concept drift. So one solution of the concept drift is time to time you need to retrain the model with the current data set collecting from the environment. Another one, again, this is very similar to that data leakage problem. Here I am just saying that this is improper learning, but the problem is more or less similar. So you see here in these 6 examples, you say this is predicted as wolf and the true level was wolf. This was predicted as husky, true level was husky. This was predicted as wolf, the true level was wolf, and so on. So the only wrong prediction it has made, the system has made, was this. Right. So if you predict, if you calculate the precision, recall, advance score, accuracy, and so on, the performance metric, because most of us just rely on that performance metrics. If the performance metrics is improved, that means I have made a very good system. And in this particular talk, I am just going to defy that. No, it's not so. So only improving on the performance is not sufficient. Why? Because you see here, out of 6 cases, only 1 case is the wrong one. In fact, in general, this system, from the source it was taken, the accuracy was around 94 or 95%. But when they wanted to see on what basis the model is predicting what is wolf and what is husky, they were surprised to see. Can anyone tell how the system was making the difference between husky and wolf? If anyone has any information, prior information about this, or if you can infer something from these images, just share your thought.
Hello, am I audible?
Yes.
Okay, it is based on basically background color.
Yes, right. Thank you, Dr. Abhijit. So the model, what the model did, what it did. So the model looked into the white color or snow. Basically, all the wolf images, if you see, if you put your attention, you see that all the wolf images are taken from the icy area, so snowy area. So there is a snow in the background, right? So whenever it sees snow, so it has the model has learned to identify snow versus non-snow. In fact, the model was targeted to learn wolf versus husky and differentiate wolf from husky. But the model learned how to differentiate icy areas or snowy regions from other regions or green regions. That's what the model learned. And you see here in this background there is it looks like snow, and hence it predicted it as wolf. So that's you think of a medical setting now. So in a medical image, you have trained a model. The model was trained, supposed to make a prediction looking at the diseased area. But the model has seen something else and it is predicting. Might be you are getting good accuracy. Is it of use, any use? No, that's not an use. And if you go for that regulatory compliance, the model will. Another problem with the machine learning model is the adversarial examples or adversarial attacks. In fact, adversarial attacks are small perturbation into the machine learning, or basically, so not into machine learning model, into the input example. So if you have a test case and if you perturb some of the samples, some of the pixels into that, it will predict totally different thing. So here if you see, the original image was of temple, and when the original image was projected or given to the model predicted it as a temple, and the confidence was around 97%. And now a random image was, random noise was added to this original image. A small random noise was added into this, and after adding this noise, the image looks like this. So if you see in a naked eye, any human being will immediately say that this is still temple. So whatever was the original image, this is still the same image. But the model where it was tested that predicted this to be ostrich, and look at the confidence level. The confidence level was 98%. So the probability of being ostrich it assigned was around 98, 198, around 1 means exactly. So the model was very confident that this is an ostrich, not a temple, because of just a small noise. But we know that we human beings are never going to make this sort of mistakes with a small noise. So that's an adversarial attacks, and a lot of work right now. You might see that robustness of machine learning models or attacks in machine learning models, deep learning models. A lot of works are going on. A lot of people are investigating into that. That's an active area of research. So there are several attacks. This is just an example of that. So that's one of the problem with this current system. Now the question is, then considering these issues, now your friend is a bit worried and again came to you suggesting, asking you, why now you tell me what to do. I'm into this regulatory, this model is sometimes giving this sort of output and so and so. Now what to make, how to improve on this model. So now as a machine learning engineer, what you are thinking that okay, if I can add some interpretation here, if I can add some layer or something which can interpret the result, that means it can say on what basis I am making this prediction, why I am making this prediction, where I am looking into this particular image or in this particular table and so and so. Probably this sort of mistakes can be minimized, if not 100% eliminated. So we are suggesting that okay, we will add an interpretation level, and that's the core of my talk. Okay, how to add to this interpretation? How to add this particular interpretation level? This is the block we are talking about. Okay, how to add this? Now, if we add this interpretation block, next thing we can do is while we deploy the model, once we have added the interpretation while testing, we can deploy the model and we can add one explanation model. Again, we'll see that there is hardly any difference between explanation and interpretation. Normally, in our talk, I will be just concentrating on interpretation, because if we have interpretation, we can make it explainable also. But most of the research nowadays are considering only the interpretation part. If the model is interpreted at least, then we can add explanation. We'll see the difference, what is difference between interpretation and explanation also. Okay, and finally, for the concept drift, we can add one more layer called as monitoring. So we will be looking into this overall accuracy. The accuracy month-wise, or say daily accuracy, total predictions were made by this, and how much accuracy daily by evening I have got. And if there is any drift in the concept, that means if the model performance is decreasing, probably I need to retrain it with the current data set, last say 2 years or 1 year's data set. That supplementary training may be given to this model also. Right. So now we want to integrate this interpretation model. Now coming to what is interpretation. So before going to the interpretation, let us use some of the terms which we will be frequently using. So normally we talk about a term, or we use a term called as black box model. So a black box model is a model which gives me, or which tells me the prediction, but not how the prediction was, the result was achieved, how it came to that result. So like there is a, say, if this model is a black box model, if I ask, why did you predict 100 for this data point? The model will not answer anything. So the model keeps silence on asking why it gave the value shown here. So in general, if we talk about black box model, a black box model is a system that doesn't reveal its internal mechanism. And in machine learning terms, it cannot be understood by looking at the parameters. So like we can see the parameters of the neural network, even deep learning models. We know that there are, say, in a general CNN model, we have several lakhs of weights. So if we look at those weights we can get at any moment. So you can copy those and store those weights in your system. You can look at them at a later time, but you cannot get any meaning from those weights. So that's what we say when we say black box in machine learning. So those weights or those parameters are not sufficient. We cannot understand anything from those parameters. Whereas an interpretable machine learning refers to the methods and model that make the behavior and prediction of these machine learning systems understandable to humans. Right. So let's see how we can do. In fact, what we are trying to see, like what we are doing right now. So upper part is what we are doing right now. The lower part is what we will do if we have an interpretable system or explainable AI. So if you see today what we are doing, we have certain images, we have a learning process, then we have make a model, say a deep learning based model like CNN or any recurrent neural network transformer based model, whatever. So we have a learned function. So if we give our data to this learned function, the input to this learned function, the function will give me an output that this is a cat, this is a dog, this is a husky, this is a wolf, and so on. If it is a medical setting, this is benign, this is malignant, and so and so. Now, if you ask, why did you do that? Why not something else? When you've succeeded, if there is any failure case, can I trust you? If you want to correct, how can I correct you? No. There is the model will be done at that particular time. It cannot say anything regarding this. Now think of the other way. If we develop a model where instead of this learned function, we have explainable model. So if we have an explainable model, what will be new? If we give a new data set, this data set will tell me that this is a cat. And then it will also tell me it is a cat. Why I am saying that? Because it has got fur, it has got whiskers, it has got claws. Since it has these features, I'm calling it, or I'm confident that this should be a cat. Now, from a human being's perspective, if you see that, now you understand why it has made this decision, why it has not made anything else. You can know how, when it will successful, when it will be, the model will be successful on particular data, when, when data it, what data it will not be able to successful. Can you trust it? So you can now assure or assign certain trust score to this. And if there is any error, there is some mistakes, the system is giving regularly correct wrong output, then you can find out where it is making that mistake, and then you can just pinpoint that, and that mistakes may be corrected. Okay, so this is what we want. So I hope I have set the problems, set the tone, why we need explainability. Now I'm coming to what interpretability, explainability is, and how to achieve that. How we can add those layers into our existing machine learning models. So obviously we are not going to throw out, yes. Please, I think someone has raised a hand for question. So now we are going to do that. So say, what is, let us define, or let us just talk about what is interpretability. So interpretability, say again, these things still, I'm saying that still the people are not very sure exactly. If you ask me what is the definition of this, so whatever I have written here, in some other book you may get a different sort of wordings and something extra along with this, or something missing from this, and so on. So in general, if you say interpretability, interpretability is the degree to which a human can understand the cause of a decision, why the decision was made, on what basis I made the decision. And also, I can consistently predict that given these features, the model should give this as output. Obviously, higher the interpretability, easier it is for someone to comprehend why certain decisions or predictions have been made. And if a model's decisions are easier for a human to understand, then we say that that particular model is better interpretable. So we can make a model interpretable in several sense. So if I have made a same module interpretable in two different ways, and if one of them is easier, then obviously that interpretability of that particular way is easier. That's what is saying the last line. Explainability. So there are two terms, interpretability and explainability. You will also frequently encounter these terms. So explainability, if you say what is explainability, explainability is a human readable form of how and why a model come up with the prediction. It explains the internal mechanism of the system in humans term, and in general, explainability requires interpretability as a building blocks. So we need to have a system interpretable in order to really make it explainable. So most of the books right now which are available, and most of the works which are referring, they normally concentrate mostly on the interpretability, because if we have interpretability, then we can in fact we can get a lot of information about that. We can explain to some extent to the human beings also. So interpretability basically refers to the model's property, and explainability in that sense you can say is how easier it is for human to understand. So that's again the same figure. If we have a black box, so to whom it is creating problem, or for whom it is difficult. So it is difficult. A black box model is difficult for everyone. Now I have just given here some types of customer. Like if you are a business owner, your concern is, can I trust this model? Really, should I go for this? But if it is interpretable, you have at least something. Customer support. Now you think of, you have applied for a loan application and your loan application was somehow rejected. You call the customer support executive. The The customer support executive tells her, we are using a AI-based system to predict that whether loan can be granted to the customers or not. And for your case, the model predicted that you cannot be given loan. You will ask why, on what basis you are saying this, or is there any way by which if we improve on that, probably I can get a loan. The customer, if it is a black box model, the customer care executive will not be in a position to say anything to you. So he will just keep down or give you something, some nonsense examples and so on. But if it is a black box, sorry, if it is an interpretable model, then the customer care executive can tell you, sir, you have very low credit score, or your income is very less, or your credit, say you are for last 5 6 years your credit scores were not good, or you have defaulted in some loan applications, and so and so. That is only possible if the model is interpretable, if there is an interpretability. If you are head of an IT organization, you want that how can, if there is some error, some problem in the model, how can I debug this? How can I improve on this model? As a data scientist, your question will be, is it the best model? Or can we improve on the accuracy more? Or can we improve this model to better predict it and so on? And the most important persons, those who are ultimately going to implement or accept and reject your model, are the internal audit or the regulators. So their question will be whether the model is fair. Is it not biased? Is it working well for all class of people, all sections of people? It is not making, is it that it is not making any discrimination based on the caste, religion, ethnicity, and so and so. Again, through a black box model, you can't say that. So for the purpose of this slide was to highlight that interpretability is something which is not required by just one group of people. In fact, all, starting from the developers to the general public to the regulators, the policy makers, everyone, if AI system has to be implemented, it has to be say some interpretability in built into this. Otherwise, it will create a lot of problem to everyone involved in this pipeline. So this slide is same thing, just the last one. So I'm not just going to repeat that. Now the question is coming to the second part of how really we can implement the interpretability. Okay. So far, I hope I'm going well. I'm able to make you understand what I'm trying to convey. Okay. So when we talk about interpretability, there are in fact the models. If we talk about model, let me go to the next figure. So when we talk about models, models can be say classified as intrinsic model and post hoc models. Say this figure. Intrinsic interpretability models are techniques, and post hoc interpretability techniques. Intrinsic interpretability techniques are those related to machine learning models with a simple structures, or also called as white box models. Like these models, this interpretability is inbuilt into the machine learning models. So there are some machine learning models which are inherently interpretable. For example, a linear regression, logistic regression, decision tree. These models are intrinsically, basically they are white box. You know how they are working, and you can predict that on what basis they have come to this decision. So they are called as, the interpretability technique which is used there is called as intrinsic interpretability technique. The model itself is interpretable. Again, I am repeating, the model itself is interpretable. You do not require anything else. So if you are using a decision tree, in fact, you do not need to worry about whether you have interpretability or not. The decision tree is inherently interpretable. You know that if this, then this, then this, then this, hence this result. So since if this and this and this and this, so you know if these conditions are true, that's why I'm coming to this answer. right? So a decision tree model is one of the basic, very interesting and very good intrinsic interpretable model. If it is a say logistic, say linear regression. So in regression, we know that a regression model is represented something like this: y equals to. सर अभी एक टॉक चल रहा है 4 बजे के बाद दे सर ठीक ठीक सर ठीक ठीक सर y equals to what we write say if I write say 50 x1 plus 30 x2 minus say 3 x3. So a logistic regression looks something like this: plus 20 or minus 20 or 10, something like this. Logistic regression looks like this. So now we know that the most important feature in this particular case is x1. This is the next important feature. This feature is not very important, and this is again taking this one, not visible. Okay. Right. Thank you, thank you. I do not know why the color is choose a color palette. Why it is not continuous. Green is visible, but somehow writings are not visible, no? Why?
Yes, sir. Writing is not visible.
Not know why it is in my screen. It is okay. The cursor is showing, but somehow the writing is not visible. This is first time it is happening like this. Pen is not working. Okay, let me move on to my standard technique. So say I hope this will be visible to everyone. So normally we write something like this. Let me make it bigger. So we write something like this. Okay, this paint is not visible. Okay, now it's okay. Okay. The way I have made window. The sharing was in window mode. So once the sharing is made in screen, the screen, then it is okay. I'm really sorry. So earlier also I made some, but that was not visible to you. So okay. Anyway, thank you for raising. That's why I regularly keep on asking. So please at least interact so that. Okay, so this is what I had written there. So if we have linear regression looks something like this. All of you have seen this sort of equations like ax1 plus a1 x1 plus a2 x2 plus a3 x3 and so on plus a0. So if we have a linear regression like this, we know that x1 is the most important feature. Because whatever will be value of x1, it will be multiplied by the most significant number, so 50, and then the result will be highly dependent on that. x3 in that sense is the least significant feature here. So this is also interpretable, by default interpretable. Right, that's what I just wanted to highlight. That linear regression, logistic regression, decision trees, these are inherently interpretable, and hence we call those models as intrinsic interpretable techniques or models, and this technique is called as intrinsic interpretability. If the model is not inherently interpretable, Then we need to have post hoc interpretability technique. We need to apply some technique which is called as post hoc interpretability technique. Post hoc interpretability technique you can assume is you have a model here. So you give your input to this model, say X. This model normally gives you an output, but you cannot interpret the result. Why it is coming. So now you think of, instead of giving this result here, if I add one layer, so this is called, say, interpretability layer. If I add one layer, interpretability layer, and then I give the output, then now we know that whenever I am getting this y, I can go through this interpretability and see why this y has come. Right. So this is what the post hoc interpretability technique says. It is usually applied after the model training are used to interpret and understand the importance of certain inputs for model prediction. This this interpretability technique, you can easily understand that it is irrespective of what sort of model is here, whether it is white box or black box. But obviously for white box model, why I should apply anything else? So, but it can be applied. If you are not satisfied with your white box model, you can in fact apply this interpretability technique post hoc also. Right? Then some interpretability technique are model specific and some are model agnostic. Model specific means the last diagram, if you again reconsider, that I have got a model. So this is my model, and I know that there is one plugin, interpretability plugin, which can be applied only to this model. So this is the interpretability plugin. This can be applied to this model M1. If I have another model, say M2, I have to use a different interpretability model, say I2. If I try to apply I1 here, I1 cannot be fitted here. So if M1 and M2 are different, I have to apply different interpretability technique or interpretability layer after this. So that then this scenario is called as model specific, because for specific model I have to come up with a specific interpretability technique. And when we talk about agnostic, then we say that okay, here it is I, here also it is I. So irrespective of what is my model, whether it is M1 or M2, I have a common interpretability model technique which can be applied to all the models. So model agnostic. So that's the meaning of agnostic. That means it is not dependent on the model, whereas in model specific, as the term says, it is dependent on the model. Then the other term or other distinction we made is local interpretability versus global interpretability. Global interpretability means in general we make a statement that loan applications can be rejected if the credit score is low. But say your loan application was rejected, but your credit score was high. If you ask, so if it is a global interpretability, it will always say, sir, if the credit score is low, your loan will be rejected. And you will be fighting with them, arguing with them, कि सर मेरा तो अच्छा है, फिर क्यों reject कर रहे हैं? Because the global interpretability understands just global feature. It's not specific to your reason, so it will not work there. Whereas in case of local interpretability, we say that if your loan is rejected, it will say about your case. In your basically your credit score is high, but might be your income is low, or you have defaulted in some loan. That's why we are not offering you any loan also for your case, not on the global scenario, average scenario. I hope I could make the distinction. Local versus global. Local means one specific instance. Global means the whole general instance, average of the instances. So in figure, if in a diagram, if we see that it can be intrinsic versus post hoc, it can be model specific versus model agnostic, it can be local versus global. In my talk, in next half an hour, I will be going through techniques which will be local and model agnostic. So I will be going through some technique, because this creates the most interesting part. If you see, it will be local. That means for every case you can give an interpretation, and it will be model agnostic. That means it can be applied to any model. It doesn't restrict itself to be specific to one model. So two such models I will explain in the next half an hour, and how they are working. They can be made, or even I have some codes also which I can show you, see how we can use those in our cases. So this is in general, if we talk about, I think by this time it is already clear to you. If we have a world, then we created data models from basically data representation. We create a black box model out of that, and then we create the interpretability model as a layer, extra layer, and then that interpretability layer is shown to the human, how this result goes. Right. So far it is, I hope it's going well. I could just give you the idea exactly what interpretability or how we can interpret, add interpretability to the existing models. Now, in order to add interpretability to existing model, we use a term called as surrogate models. You can see from this title, we are going to use a type called as surrogate model. Surrogate, we know, something which is on higher, we take a higher of that. So a surrogate model is in fact a new model, in fact, but it is very simple. So now let me just again draw something. So say you have a model here, to say, and this is a complex black box model. So I'm writing it as BB, black box model. So we have a black box model. We have created this black box model. Now, in order to create this black box model, if you think of, you need to have some data. So you had a X, you had a Y. I hope all of you will agree with this. If I want to create a black box model, a complex black box model, I need to have sufficient amount of data, X and their level Y. So we had such data sets, we created a complex black box model. Now I am going to create a surrogate model. Now to create a surrogate model, so here I am going to create a surrogate model. Now how to create that surrogate model? So to create a surrogate model, the first line says select a dataset X. Now this dataset can be this one itself, so you can take X, or you can create a new dataset from this distribution X, right? X, so let me just go to because this is something which is really bit, you can say, requires some sorry. So say now what I was saying is I'm going to create a surrogate model. So I'm going to create a surrogate model. Now for this surrogate model, I need an input, and obviously I need a target variable. So I need X and I need Y. Now the question is, if you go through this line, so go through this line, select a dataset X, maybe the same dataset used for training the black box model, or a new dataset from the same distribution. Even a subset of the data are grid of points. Right. Now I'm coming to that only. So I had a dataset. So say I had some dataset like this, distributed here. So data sample was looking something like this. This was the area where my data set, if I plot all the variables, all the X values in the data set, this is how the data set will look like. In this area, they will fall. If you read again, it may look to you that sir is unnecessary taking long time, but this is in fact the idea. If you know this idea, then everything else is quite simple. Maybe the same data set, so I can use the same whole X for this task, or a new data set from the same distribution. Sometimes, in fact, most of the time, we need to create a new data set from this distribution. Now the question is how to create. Using that same data set is good enough. That's simple. That's already there. But most of the time, you will see that this is not working because this data set X may be huge. And training a simple model, surrogate models are always going to be simple models like decision tree or logistic regression, this linear regression, and so on. So they are going to be basic, intrinsic, interpretable models. They are simple models. Now you think that you had a black box model. A black box model was a deep neural network. So you think of what accuracy a deep neural network was achieving. Can you achieve the same accuracy with this simple logistic regression? No, that cannot be. That cannot be the case. कभी नहीं होगा. No one. So what we are going to do ultimately, what we are going to achieve. So we are going to create a new data set. Most of the time we create new data set. So how to create new data set? Say, I select a data set at this point, this point. Now you may ask, if I ask you, since you are not asking, if I ask you, okay, how I can get these rate points, can anyone suggest me? I had the black points. Now I am saying that I am going to get this rate points. I am going to generate this rate points. Can anyone suggest me how I can get how I can generate these rate points?
Adding noise.
Yes, please.
We can add noise.
And
Adding noise.
noise.
Yes, yes.
Noise is not a very good idea. It has to again put into that distribution only. So the noise has to be created from that distribution. Okay, that can be. It's sort of noise only, but what is the way? Even if you say adding noise, so how you will create that noise in that distribution itself?
Uh, Normal distribution noise.
No, not normal distribution because the distribution has to be same. Then only we will be in this area. No.
Mm-hmm.
So you have a bounded area. I told that the data set should fall into this distribution only. So I have to ensure that they are falling into this distribution only. Okay, let me just give you an example. So what I am saying is, say I have got some features here. Say x1, x2, x3, and say sorry, x2 and x3, and I have level y. And now say the value was 1, 0, 1, 0, 1, 1, say 0.5, 0.7, 0.9, and there are some levels associated with that. So again, same sort of, you can say that can be considered as noises also, but to ensure that they are falling into the same domain or same area, what we do normally is, if you just slightly change this value. So from 1, if you make it 0.9, say if you make it 0.9, now you will see that if that was the original, if say if this was the original data set 101, now your new data set will be somewhere here. Whether you agree with this or not,
Yes.
right?
Yes, there will be slight change in the position of the data set.
Yes, it will be very close to that.
Mm-hmm.
And similarly, you think of if you want to generate 100 data, you can take this sort of 100 rows, and if you slightly perturb them, you will be getting some nearby points to this data points, isn't it?
Yes, yes.
So that's a way. That is one way. I'm not saying this is the only way. That's one way. That's the easier way we can do.
Data
Now,
augmentation.
yes,
Augmentation.
yes, we are augmented. In that sense, you can say obviously we are augmented. But these are going to be used for separate story, separate model, not for the original model. Okay, so in that sense, this is not augmenting the original data. This is in fact a new data set created for the purpose of training the surrogate models.
Okay.
But obviously, the procedure is just like augmentation. Why I am not saying that this is augmentation? Because normally in augmentation, what we do, we have some data set, we create some new data, and then we add everything to train a model. Then we say it's augmentation. But this time we are not going to do that. We are creating some new data. That data will be used solely for the purpose of training this surrogate model. This data will be used to train this model. Now that's one part only. So far we have only generated the data samples X. Now what will be Y of this X? So we have created X prime from this X. So you had X, now you have created X prime. Now how to create Y prime? So one answer is, or one way we do it is, now you give this X prime to this complex model. If you give this X prime to this complex model will give you some output, predict some output, and say that is what we are calling it as Y prime. Am I clear?
Yes, sir.
I have got X, I need to have Y also. So in normal course of action, annotation is done, someone has done manually. Now I'm not going to do manually because we do not have resources for that. So what we do, we give this X prime to this black box model. This black box model will give me some output. That output is now labeled or given as a label to this X prime. And now my data set is over, created. So now coming to the slides again. So we have created a data set. Now for the selected data set, get the predictions of black box model. This is also what we did, Y prime we got. Now you select an interpretable model. So you select a linear model, so like linear regression, logistic regression, decision tree, whatever. And you train this model with the newly created data set X. Whatever data set you have got created, I have created X prime. So you train this model with X prime and label is Y prime. And then while you are doing so, you check the predictions of this black box, surrogate model, and compare it with the prediction of black box model, how good it is with that black box model. If they are close enough, then you say that okay, my surrogate model is ready. Once you have the surrogate model ready, then what you have made so far is just erase this points. Sorry. So now what we did is we give now here a new test sample. We give a test sample, and this test sample will basically will pass through this. This test sample is directly given to this. The same test sample also comes to this. This line is not there. So you get an output here. Y, or in fact, you can take this output from this surrogate model itself. So you give a test sample, this black box and the surrogate model, you get an output Y. And now you know, once you have got the output, you know even how it has come to this. So what was the logic behind this? So you know the interpretation of this surrogate model because this is a linear interpretation. So basically you have bypassed this black box model or approximated this black box model with a surrogate model. So this is what is done in a case of, so interpret the surrogate model. I hope I will now take two examples of this scenario. So the first example is called as our first use case, our first type of model which are available are called as line. They are popularly known as the term line. So line. Line. Local interpretable. So this is the full form of this. Local interpretable model agnostic explanations. Line in short. So how line works? The idea is same what I just discussed. So you had a black box model, you have some X, you created, you have some label for that. So like a black box model, like say neural network. Then you train a linear model. So as I told, so you create a surrogate model, and then you check the outputs, how close they are. So if they are close enough, you can stop and say that okay, this is my interpretable model now, and you can get interpretation from that. So, say consider an example of say, an image, how live works, or how that I just told. No, okay, I will create some data set by replacing 1 with point 0.9. How exactly it is done in practice? Say you have an image of say a frog. What we are doing is we are creating a lot of test cases from this image only. So what we are doing is we are just fragmenting this image into several components. So every this sort of area is in fact it will give me some image. So you see here I have taken, so from this image itself I have created one image, another image, another image, and so on. So you can create 10, 15 images similar to this. And then you see you pass this image to the black box model, and the black box model has given its output as 0.85. That means this is a frog. To this 0.52, still this is a frog. This 0.01, that means this is not a frog. And now similarly you give so many images, so you have created so many data points. So these are now my data points. So x prime, the x prime which I was just talking about. So this is the x primes. So this whole set represents my x prime. I have created several data points from the single data point, and their level is obtained by this black box model. So it is confident that this is frog with a probability of 0.85. I hope, is it clear? If no, then please raise your hand, please ask. Implementing this is not very difficult. The only thing, if you have some idea, then probably you can go through the other books and materials available online, and you can again go through this. So now you have so many data sets. So then you pass it through a linear model, and then your linear model will give you some output. And if your linear model is coming closer to this, then you stop and then you say that, okay, this linear model is my interpretable model. And then now whenever you are giving any image, it will go through that linear model and it will give its probability. If the probability is 0.85, that means it is a frog. Why it is frog? Now you can give an explanation, because I can see these two eyes, I can see this sort of mouth structure, I can see this sort of hand structure. Hence, I am saying that this is a frog. Right? So, it's interpretation it has given. Interpretation means what? In case of image, that also you should remember that in case of image, when you say interpretation, highlighting the specific area is the interpretation. If it is text, highlighting certain text portion is an interpretation. If it is data, obviously the data point. If it is tabular data, then tabular data point. So line package is available for both tabular, so for all, in fact, for tabular data, for text related data, that means NLP data, and as well as for image data. So this package is available for everyone. Mathematically, if you want to go through, or if you want how it is working, this is how. So you have a classifier and number of samples, you create an instance, interpretable version, and then you go through this. Normally we minimize this sort of loss function. In general, this is the loss function, the black box model, and this is approximate model, and this is how the model's complexity is controlled. This is from NLP example. So if you have natural language processing text, and if you apply NLP, like here say it was classification of Catholicism versus Christian. So it has highlighted certain words, and it is classifying this at atheism because of these highlighted words. So see here, it has given that this color is referring to this one, and these are the words, and this is also given how much the importance of those words. So this you can use. So in general, this is how it works. So extractor, classifier, text, extractor, and classifier. So you have highlighted this, you have highlighted this. That's the interpretation. Right. Another very important local interpretability technique is called as Shapley additive explanation or SAP, SHAP, SAP. Another important feature one is called as SAP. This is another very important way of interpretation. In fact, this idea or this gentleman SAP, in fact, is called as Lord Shapley. Lord Shapley, uh, in fact, introduced this idea in 1953. You know, in fact, none of us might have, most of us, like, those who are attending, if you are not very old, then we are not born at that particular time. So much before that. And he won a Nobel Prize in economics in the year 2012 for this idea. So after a gap of around 61 years. And this idea of this cooperative game, what he applied, in fact, started getting quite popularity in case of explaining the machine learning model in very recently. I think the first paper appeared in 2016 or 17 somewhere. So 2016-17, people have started showing a lot of interest in this area of using this Shapley interpretation or Shapley value. Now let's see what Shapley is. So Shapley value is proposed for a cooperative game and obviously for the economists. So the idea was if it's a collaborative game like say cricket, football, where a number of players are playing. Say there are M players playing that particular game. Think of a company employee and a company creating some profit. So say 11 players are playing cricket, and then they are winning a trophy, finally a trophy. Now the question is, at the end of the tournament, if you want to find out who has contributed most, so you can say are the runs or the number of wickets, they are one of the figures. But most of the time, we might have also seen that while it's cricket, football, anything else, the since it is a cooperative game, the other player who is there on the other side has also contributed. Might be that goal or that run has not credited to his account, but he was equally a part of that. If a player is running, the other player is also running, but the run goes into one's kitty only. If a player is making a goal, he has been passed that ball from someone else. So can you say that the goal is only scored by that player? No. And that's where the idea of Shapley, Lord Shapley was very effective. I hope this idea is appealing enough, good enough. In fact, when I studied this idea for the first time, I was really impressed and it created a lot of interest of mine into this idea. So that's why I'm really they are very interested in this idea. So say I'm just showing you an example here. There are two people, say Alice and Bob, and they are hired for a company. And now company wants to make what is the contribution of Alice and what is the contribution of Bob. So how to do this? So one simple way, so simple example I am showing here is, if no employee was hired by the company made no profit. So no employee, no profit. So value was 0. Then company hired Alice alone, and company found that they get a profit of 20 units. So you can say the value of addition of Alice is 20. Then they rest Alice for some time and hired Bob, and in that particular month they found that Bob during that month, keeping everything else same, the profit was 10 unit. And then they hired basically added to both of them in the team and asked them to work for them. And when both of them worked, the profit was 50. So you see the difference. Individually, one make 20, the other make 10, but when they combine together, they make 50. Now, if there has to be a bonus, how much bonus should be given to Alice? How much bonus should be given to Bob? That's the question. So, a value called as marginal value for Alice and marginal value for Bob is calculated. So the Alice and Bob together is 50. When Alice was alone, the profit was 20 alone. So when Bob was added, 30 unit extra was achieved. So that marginal is given to Bob. Similarly, when Bob and Alice were together, it was 50. But when Bob was alone, it was 10. When Alice was added, it was 50. So the marginal for Alice should be 40. And if you take average of this, you will find out that the marginal for Alice will be 30 and marginal for Bob will be 20. So out of this 50, you can say that Bob's margin is 20 and Alice's margin is 30. So that's a way he introduced in that 1953. Now the question is, how sir, how can we use this to explain something? Yes, how we can explain it. Now you think of, say, let me just take this page only. You think that you have got some features, say F1, F2, any machine learning models. Those who have worked with machine learning models, they have already experienced this. Sometimes these features can be thousands. So I'm just concentrating that there are say 5 features. Now with this 5 feature, if you can find out which feature is important for me, or how much margin should be given to each feature. So these features are very similar to this Alice and Bob. So you can say this is Alice, this is Bob, this feature is some Charlie, this is John, this is Thornton, and so on. And similarly, you can make a profit. So what you do with no feature, you will have some base cases. If you add one feature, what is the classification accuracy? If you add 2 feature, what is the accuracy? If you add 3 feature, what is the accuracy? If you add 4 feature, what is the accuracy? If you add 5 feature, what is the accuracy? And you take it for all the permutations. And if you calculate the marginals for all the cases, what you will have is, you will have a marginal, say for all the features, F1, F2, F3, F4, F5. And then you know that which of them is having the highest value. Then you can say that probably say if you get that F3 is having the highest margin, then you see that, or you can say that sir, F3 is the most important feature for me, right? And you can give your interpretation based on that F3. Okay, F3 is the most important. So in your case, F3 is applying this much and hence this result. In fact, we have just seen Lime, we have seen Shapley. If you compare Lime and Shapley, these are 2 very important packages nowadays. If you compare these 2, Shapley have got axiometric justification. Like dummy player, a player doesn't contribute, any subset of player must receive 0 attribution. Efficiency, attribution must be added to the total gain. It is symmetry. Symmetry, player must receive equal attribution, and it is linear. So if you keep on adding, it keeps on increased in a linear way. So since this has got a mathematical and axiometric justification, people are highly interested in this one, and a lot of work, in fact recently a lot of paper have appeared in this one. Computing is really tough. That's the problem. In fact, if you have quite a good number of features, then most of the time you will see that your computing resources are exhausted with this computing Shapley value computation. So nowadays people are, in fact, a lot of research are coming up to improve on the computation of the Shapley values. How we can make the computation of the Shapley value faster. 2 popular approaches are, we use permutation based approach and subset based approach. So if you go with the subset based approach, the minimum complexity is 2 to the power m. Even if m is say 30 or 40 number of features, we assume that this is basically becoming intractable problem. This itself is even higher. So that's the problem with this. So as I have already told this, you can consider this layers to be features of the input, and your gain is the model prediction level. So then you can adjust it. So to conclude this session, I hope that I have justified the need of interpretability in machine learning in healthcare applications. I've explained what are the different types or categories of interpretability we can define. Then I explained a type of just the local surrogate models, although this literature is now getting quite uh, thick and quite rich day by day. Uh, there are a lot of gradient-based methods which are used in the deep learning models and counterfactual examples, like in loan examples. The only thing we have discussed in this particular topic was we were interested in if how this has occurred. But say if you are a loan applicant and if you ask, sir, मैं क्या करूं, what I should do so that I can get a loan. So those cases can be explained with counterfactual examples. So this is again gaining a lot of popularity in recent time. So that's all. If you want to, if you really, if this topic looks interesting to you, these are some books. In fact, this book by Christopher Moller, this is available free because this is a Creative Commons license. So you can download it from the websites. And the other books are also available through the in market, so you can go through. That's all from my side. Thank you. If you have any question.
Any question? So thank you, sir, for enlightening your lecture on explainable machine learning models for healthcare applications. Your virtual presentation skillfully detailed the development of ML model through diagnostic uses such as blood sample analysis and early breast cancer detection, highlighting their crucial role in improving healthcare outcomes. Your explanation of explainability and interpretability was particularly impactful, emphasizing the importance of transparency and trust in AI systems, especially in medical settings. You also introduced us the concept of surrogate models, which simplify complex model predictions into more understandable forms, enhancing user trust and usability. Moreover, you addressed significant challenges like data leakage and improper learning. Their models fail to perform well outside their training data, leading to potential inaccuracy in real-world applications. These insights are vital for us as we look to implement and navigate AI technology effectively. Your sessions provided a comprehensive overview of how machine learning can be applied thoughtfully and responsibly in healthcare. We are grateful for your knowledge and inspired to integrate this insight into our future project. Thank you again for a truly informative and inspiring presentation. Thank you so much, sir.
Thank you everyone. Thank you to all the participants and to Dr. Jobe. So it's really nice. So bye. Power has also gone, so I'm leaving. Okay, bye. Bye. Thank you. Thank you.
Thank you, sir. So we are having break for 20 minutes. We'll join by 4:20. Okay. Be online, please. No need to leave. Take tea, and those who are virtually joined, they will enjoy there. Okay. So next session will be start by 4:20. Please be online. No need to leave.
Hi, hello, sir. I am here. Can you hear me?
Yes, yes, ma'am.
Okay. Yeah.
So, okay. Hello, madam. Can you hear me?
Yes, sir. Yes, sir. I can hear you, sir.
Okay.
Yeah.
So, I'm Dr. Ujjwal Vishwas from the Department of Computer Science and Engineering, IIT Bhagalpur, the co-coordinator of this course. Now, I'm privileged to introduce our next speaker, Dr. Siparna Shah. She is currently serving as an associate professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Patna, India. She has published more than 400 papers. Her current research, her current research include machine learning, deep learning, natural language processing, and multi-objective optimization and biomedical information extraction. Her ACE index is 40 and total citation count now is 8,807 according to the Google Scholar information. She is also a senior member of ACM IEEE, a fellow of IET UK and IET. She received various awards in this research field such as Young Engineer Award, Women Engineering Award, and many more. She is currently also serving as the associate editor IEEE ACM Transaction on Computational Biology and Bioinformatics. IEEE Transaction on Computational Social Systems, IEEE Transaction on AI, ACM Transaction on Asian and Low Resource Language Information Processing, Expert System with Application, and IEEE Internet Computing, Engineering Application of Artificial Intelligence. Her name is included in the list of top 2% scientists of their main subtle discipline like artificial intelligence and image processing. So I would like to invite Dr. Siparna Shah to start her presentation. Thank you, ma'am. Thank you very much.
Yeah. I hope I am audible.
Yes, yes, ma'am.
Yeah. Okay. So, I is my skin visible? Yes.
Yes, ma'am. Yes.
So I will be talking about this charting the new territories, multimodal information processing in NLP through deep learning, and nowadays, as you know, that language processing has also been introduced. Yeah. Any question? So we, that large language model has also been introduced. So we'll be also discussing about the large language models. So how LLMs can be also introduced for the multimodal information processing. So yeah, so that will be the like in my particular talk, I'll be mostly discussing about the multimodal information processing and how deep learning techniques can be used for multimodal information processing, and later on how the that language modeling techniques can be used for that particular purpose. And already introduced, so I am currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. And you can also go through my webpage www.iitp.ac.in tilde Sriparna, and you can see my publications. All my publications are listed in my web page. and you can download, and we are also developing many resources because we are working in the field of natural language processing, and you know that there are many Indian languages, and in many cases we have to develop our own data sets. So all these data sets are available in my web page, and there is a resource page of my web page, and in this resource page all the data sets are available. So you can also download these resources, and you can those resources are freely available, and you can then utilize those resources for your own research. So we have created several resources for in many research domains, and those are available online. So basically in IIT Patna, you know that there is a research team, and there are many PhD students, almost 12 PhD students, and we are regularly publishing our public papers in top tier conferences and journals, and mostly we are publishing in basically these PhD students are working on many cutting edge research problems of natural language processing, machine learning, deep learning, and many societal problem statements. We have tie ups with many industries like that Sony Research India, Adobe, Accenture, Crisil, LG Soft, LCVR, Roynet, so Microsoft. So with several industries we are also working on, and in collaboration with them we are trying to solve many industrial problems. For example, with Sony we are working on recommendation systems, because recommendation system is nowadays a very challenging problem. There are OTT platforms, and in the OTT platforms we are nowadays watching mostly films in the Netflix or in the Amazon Prime or Disney, but there are many OTT platforms, and recommendation system is a very challenging problem. You know that people are Sony Live is working on how to make the recommendation system more efficient, and they are basically, we also introduce the multimodality, like instead of working on only the metadata information of the movies, the cast, crew, or the director, or all those information of the movies. We are also considering the trailers of the movie. When we are considering the movie to movie similarity, we are also considering the trailers of the movie. So we formulated the problem of recommendation as a multimodal problem. So mostly in the recent years, our focus is on multimodal information processing, and that we are basically we are working on how we can incorporate the multimodality in solving various tasks. So basically, let me first introduce this task. What is the multimodality? So you know that our experience of the world is multimodal. So as a human being, whenever we have to take decisions about an object, we are basically using our multiple sensors. Like we are seeing the object, we are hearing the sound of the object, we are feeling the texture of the object, we are smelling the odors of the object, we are tasting the flavor of the object. And after considering the all these all these basically, after using our multiple sensors, we are collecting the information, and after that we are taking a decision. So basically we are having multiple sensors or multiple organs, and by using multiple organs we are collecting information from different sources, and then we are taking a decision. So basically our experience of the world is basically multimodal. So multimodal learning is basically consolidating the heterogeneous data from various sensors and data inputs into a single model. So we have to collect information from different sources, And then when you collect information from different sources, then you can simply combine the information from different sources into a single source, and then you can take a decision. So that is basically called the multimodal information processing. That you have heterogeneous information sources, you try to collect the data from heterogeneous information sources, and then you take a decision. So, the approach of training models on a only single source of information, such as either text, audio, or video, is commonplace. But in many domains like social media, or newspaper, or even in the biomedical domain also. Like in the biomedical domain, also for a patient, we can have multimodal in data. Like if you can see a cancer patient, for a cancer patient we have the genetic history, we have the image data, tumor image data of the patient, we have the blood related information about the tumor. So we have so many different sources of information. So if we can consider all these sources of information, and then they can consider can then solve a particular problem. Problem can be anything. The problem could be, the predicting whether the patient will survive for more than 5 years or less than 5 years. Or we can also predict the severity of the patient, whether what is the severity of the cancer patient, whether the severity is very mild, or it is or it is very highly severe, or it is at the initial stage. So that way, in every domain, for example, social media, whenever we are writing some complaint, suppose we purchase some product from the Amazon or any online platform, but we are not happy when the item was delivered, we are not happy with the product. So basically, we are writing the complaint about the particular product. So we are not only writing the textual complaint, but also we are uploading the image of the particular product, or sometimes we are also uploading the video of the particular defected product. So that way this complaint is also multimodal. It is not only image plus text, but it could be also image plus video plus text. So that way there are so many cases or many examples where the data is having multimodal input. So data can have multiple sources of information, and now we have to we consider these multiple sources of information to predict an output. So this is an example of multimodal information processing. So, you know that why the multimodal information processing is important, because you know that languages restrict people to communicate their thoughts with others who speak the same language. Like if we want to communicate with each other, then we should know each other's language. But so many official languages are there. Like for example, in India, there are around 26 official languages, so it is very difficult to know all each and every official language. So, but however, the gift of sight is something shared universally with everyone. But we have the gift of sight, which is something shared universally with everyone. So, you know that somehow visually we can see many items. So, that way, image is a very important modality. So it is hard to express abstract concepts like freedom, gravity, etc. through images, while it can be expressed through text conveniently. Like that there are concepts like freedom, gravity, etc. So which can be very difficult to express using images, but we can easily express the concept like freedom, gravity using a text. But how a piano looks like, or how a pangolin looks like, it is very difficult to describe using text. So in that case image can help. So image and text are complementary to each other, so some concepts can be better described using text, and some concepts can be better described using image. So this way image and text are complementary to each other, and we should have both the modalities for expressing the concepts in a better way. So basically, multimodal information processing is getting very popularity in natural language processing, because in natural language processing there are several tasks, like emotion and sentiment analysis, summarization, complaint mining, dialogue systems, where we need to have multiple modalities, like at least two modalities, like image plus text, to express the to express the user. For example, we can use the multimodality for emotion detection in a dialogue, like what the user is trying to say. So suppose user is saying something, so can we detect the appropriate emotion of a particular user, like you liked it, you really liked it. So suppose speaker is there is a two party conversation, there are two speakers, and we would like to detect the emotion of a particular speaker. Okay, so it could be a two party dialogue or it could be a multi party dialogue, and we would like to identify the emotion or the sentiment of a particular speaker. So you know that, oh yes, so we understand this is a basically emotion is basically joy and the sentiment is positive. Which part exactly? So here the emotion is neutral and the sentiment is neutral. The whole thing, can we go here also the emotion is neutral and the sentiment is neutral. What about the scene with the kangaroo? Here the emotion is basically neutral, sentiment is neutral. I was surprised to see a kangaroo in a worldwide epic. So here the new sentiment, new emotion is new surprised, and the sentiment is negative. So this way, you know that the speaker is by seeing. So here there are three modalities. We are not only considering what the user is saying, like the textual modality is obviously an important modality, but we are also considering the speaker's facial expressions and also the speaker's audio tone. So the facial expressions are important and also the audio tones are important. So after considering the facial expressions and the audio tone and also the textual utterances, we are determining the appropriate sentiment and emotion of the particular speaker. So this is basically called the sentiment and emotion recognition from the from a dialogue. So two speakers are conversing, and we are detecting the sentiment and emotion of the particular from a particular dialogue. So the other task is basically the summarization. So you know that suppose there is a disaster has happened, and during the disaster time, you know that you people used to post about their situation in the social media. So they used to post how many people got stuck in a particular building, and then what is the situation in the particular building. So all the current situation they used to post in the social media. So now can we collect all the posts related to a particular disaster from the social media, and then can we categorize those posts into two categories, informative and non-informative, because all the posts are not relevant. So some posts contain information and some posts are not relevant for generating the summary, because some posts are only sympathetic in nature. So there is not much informational content in those posts. So we are only considering those posts where some informational content are present. So this way at first, so here also the each tweet is having two modalities, the image and the text. So image part and the text part, there are two modalities. We are considering both the modalities, and then we are categorizing the tweet into two categories, informational and non-informational. And then after considering all the informational tweets, we are summarizing all the tweets into we are generating a summary from the all the informational tweets. So that is the task we are doing. So basically, that is the task we are doing. So here there is a two-stage approach. In the first stage, we are categorizing the tweets into two categories: the informational and non-informational, and then all the informational tweets are further summarized together, and we are generating a summary out of that. So these are the two prominent examples of natural language processing where the multimodal information processing can be applied. So, as I mentioned that in recent years, my team is mostly focusing on multimodal information processing. So we realized long back, I think in the year 2016, or from the 2016-17 onwards, that text is not enough, or a single modality is not enough. If you are solving the problems of natural language processing, or you are solving the problem of bioinformatics, if you are relying on a single source of data, that is not enough. In order to increase the accuracy of the model, we need to gather data from multiple sources. So we started exploring the multimodal information processing, either in the area of natural language processing or in the problem statements of bioinformatics. So we solve different problems in natural language processing, like in dialogue systems. You know that Alexa, Siri, we are regularly using our day-to-day life. We are giving many instructions to Alexa, that switch on the TV, or switch on the AC, or that give me the weather update, give me the some top 10 news of today. So this way, Alexa is mostly used as our personal assistant. So now, if Alexa can also understand some images, can also get some instructions from some images. If Alexa can also become multimodal. So this way, we have also incorporated the multimodality in the dialogue systems. So now the Alexa or the Siri can also take instructions from the images. Like if suppose the user is not able to express some information in text, then the user can also express the information in terms of image. Like maybe the user is not confident, user is not aware of a color name. So in that case, user can simply show the image of the color, and maybe the Alexa or Siri can simply understand the color name from the image. We also worked on in the healthcare domain. In the healthcare domain, there was a lack of dialogue systems. So that especially in the mental health domain. So in the mental health domain, whenever we are suffering from some mental disorders, especially in India, there is a stigma that we do not go to the hospitals, or we do not go to consult a psychiatrist or a psychologist. Because of the societal stigma, we used to hide our mental health issues. So and it is very very significantly important for the students, because students often suffer from many mental health disorders. And there are different mental health disorders like depression, anxiety, bipolar disorder, and several other issues. So, and depending on the mental health disorder type, there are different counseling path. It's not a uniform counseling path, but depending on a mental health disorder type, psychologists or the psychiatrists used to follow a different psychological counseling. So, can we develop a chatbot, or simply a shoulder to cry on, or a first point of contact for the mental health patient suffering from some health disorder, or a person suffering from in mental distress, which can simply discuss his or her mental issues with this chatbot. And the chatbot can simply generate some motivational and some sympathetic responses. So see, our motivation is not to replace the psychiatrist or the psychologist with a chatbot, because we are also considering the ethical issues of AI. So it is not at all possible to replace the psychiatrist with a chatbot. We only want to help the psychiatrist, because if you see in India, the ratio of the psychiatrist versus the number of people who are suffering from mental disorders is really alarming. So we really need to have some AI-based assistant which can help the psychiatrist to reach out more number of people who need some help, who are suffering from some mental disorders, but they need some immediate attention. So there AI can help, or the AI NLP can help. So that we develop this kind of motivational chatbot. So these motivational chatbots are, as I mentioned, these are some fast point of contact. So they can be installed in the mobile phones, and the use and the user can simply chat with this AI assistant. They can discuss their mental issues with the bot, and the bot can simply generate some motivational, say, empathetic responses, and give some positive suggestions just to improve their mental health. And if it sees that no, there is no improvement in the mental health, then maybe it can redirect, it can basically generate an alarm, and it can request the patient to contact some psychiatrist. So this is basically called the motivational chatbot that we have also developed. And also we developed, like one of my students who has just graduated, who was a prime minister research fellow. So prime minister research fellowship is a very prestigious fellowship, and there are very few students in the all over the world, all over the India, who received this prime minister research fellowship, which is a very unique kind of fellowship schema started by the government of India. And as a part of this, students used to get a huge amount of fellowship, and also a good amount of contingency grant to present their research works in international conferences, and workshops. And he basically developed a virtual doctor, and he also started his own startup called the clinicalassistance.com. So basically, again, it is not for the mental health, but it is on the physical health. So basically, the idea is very simple, that whenever we are visiting a hospital, so in a big hospital like Apollo or AIMS, there are many departments. Like there are departments like ENT, or the neurology, or the gynecology, or the surgery department. There are many departments in a big hospital. So whenever a patient is going to a big hospital, there is a receptionist. The patient is going with his or her self report. Now the receptionist is guiding the patient to go to a particular department depending on the self report. Like if I will mention that I am suffering from some gynecological issues, then the receptionist will guide me to go to the gynecological department. Now in the gynecological department, there are some junior doctors and there are some senior doctors. Now the junior doctors are mostly the interns, and they will do some further symptom investigations, and they will ask about some additional symptoms. And then they will generate a report, and this report will be verified by the senior doctor. And finally the senior doctor will prescribe some medicines, and all the senior doctor will prescribe some medicine, and also will prescribe whether that what kind of meditation the patient should take, and also some medical test should be done or not. So this is the whole process. So now the idea is that in order to reduce the load to the doctors, can we replace these junior doctors by a AI assistant? So can we replace the junior doctors by a AI assistant or a chatbot which can help in symptom investigations? So these AI assistants will basically do the symptom investigations. They will ask about some additional symptoms, and finally a report will be generated, and this report will be verified by the senior doctors. So again, I am repeatedly telling that our task is not to replace the doctors, rather to assist the doctor, because in India the doctor patient ratio is very alarming. So that's why we just want to we want to reduce the load of the doctors by doing the symptom, by performing the symptom investigation by a by AI based assistant. So this is our developing a virtual doctor, and as I mentioned that we submitted a patent out of this, and my student has also started his own startup on this concept. So yeah, so basically here also we introduce the multimodality in a sense that when the person is doing the symptom investigation, you know that suppose if the doctor is asking me about a symptom and I am not aware of the name of the symptom, then maybe I can also show the image of the symptom. Like for example, mouth ulcer or the skin rash or the redness in the eye. So all these symptoms can be easily shown by the image, because I may not know the exact medical name of the symptoms. So I can simply show the the image of the symptom. Like I can show the image, and from the image, the chatbot or the conversational agent can extract the name of the symptom. So, like for example, the mouth ulcer, the patient can show the image, and from the image there is an image identification module. The image identification module will extract the symptom name. So this is the multimodal information processing. So I will discuss about few of these tasks that my lab is doing, where we are basically applying the multimodal information processing for solving the task of this, as I mentioned, the healthcare or in natural language processing. But yeah, I hope I am audible, no? And any question up to this point? Yeah, Vivekanand.
Yes, madam.
Yeah, Dilipji, this workshop, what is the theme of this workshop?
Machine learning model, healthcare, agriculture.
What, Dilipji?
Machine learning, healthcare, and agriculture.
Okay. Yeah, there was a question from somewhere. Someone has raised the hand. Vivek or some Vivekanand or someone. So can he ask the question or?
What is this question?
No, someone who has
Yeah.
raised the hand. I just saw someone.
Is
has raised-
there anyone who have any questions in that? No, ma'am. I feel you continue, please.
Okay, sure.
Thank you, ma'am.
Okay, yeah. So let me continue with the first work, which is on this motivational chatbot. Okay, So developing some, as I mentioned, that we develop some motivational chatbot for the people who are suffering from mental distress. So this is the motivation that an estimated 970 million individuals are suffering from some sort of mental or neural diseases, making it one of the primary causes of disability globally. So, according to a recent WHO survey, more than 300 million individuals worldwide suffer from depression, a drastic increase of 18% between 2005 and 2015. However, poor access, stigmatized experience, and prejudices presumably restrict the clinical care to just 15% of the ones affected. So there are some works already, but none of them has developed any chatbot for the for the people who are suffering from some mental disorders. Okay, there are some works to detect multimodal depression detection from the dialogue. That there are some study to understand the mental health of anonymous users of Reddit, multimodal depression detection in Twitter, but there is no work in developing some chatbot for patients who are suffering from some mental disorders. Okay, so we are the first one to start working on developing some chatbot for patients who are suffering from some mental diseases. So several text-based peer-to-peer support systems like talklive.co, psychocentral.org are frequently used by millions of people seeking emotional or mental health based support. Okay, so that there are some forums, and in these forums people are discussing about their mental health issues. So in the western countries like UK, USA, these medical forums are very popularly used. Like, these are called the peer-to-peer support systems. And in these peer-to-peer support systems, what they are doing is that they are they are somehow registering, and then they are discussing about their mental issues. So they are discussing about the mental issues. So basically, that several text-based peer-to-peer support systems are frequently used by millions of people seeking emotional or mental health-based support. So it is often insufficient to provide best practices in therapy, resulting in missed opportunities for producing useful and mutually engaging responses. So what we need is that we need a support care, or we need to develop a human computer interface in the form of virtual assistant that can effectively rely on reply and provide support to online support seekers becomes extremely critical. So basically we need to develop some virtual assistant which can provide the agent some human like support system. So that empathy or empathetic interactions is one of the fundamental factors in providing successful support, triggering positive outcomes in support-based conversations. And also, whenever the person is suffering from some depression, we need to provide him some hope and motivations. So, apart from empathy, imparting hope and motivations are also key effective factors to uplift the spirit of the support seekers in distress in supportive conversations. For the VA to provide a conversational support, it is critical to recognize and differentiate various mental diseases. So that to the best of our knowledge, there was no virtual assistant which can provide any motivational support to the support seeker. So what we did is that we developed two framework. One is the mental illness classification. So in the first stage, Suppose you are talking to suppose a patient which is suffering from some mental disorder. So you have to classify what is the mental disorder type, whether the patient is suffering, whether the patient is suffering from depression or the anxiety or the bipolar disorder, or what is the type of the mental disorder. That at the first stage you have to classify, and then in the second stage, based on the mental disorder type, we need to generate the responses. So that there are two sub modules. One is the mental illness classification framework, and the second is the mental illness conditioned motivational dialogue generation. So there are two modules. One is that suppose the person is talking with the virtual agent. So after few iterations, based on this dialogue, we have to understand what is the mental illness. We have to classify the mental illness. And then the second stage, we have to, there is a mental illness condition motivational dialogue generation. So you have to develop the dialogue based on the mental illness. So you know that whenever you are, if you want to develop some that dialogue generation module, we need to create a data set. So in order to create a data set, there was no existing data set. So we created our own data set, which is called the motive. Now, this motive dataset is a conversational dataset to advance the research in mental health based support. So, motive is a dataset which is advancing the research in the mental health based support. So motivational VA or the motive is basically the here the VA's effort is directed towards comforting and allowing the users to share and express their thoughts, moods, feelings, emotions, struggles, and worries. The virtual agent should impart optimism, hope, motivation, which are identified as crucial effective factors to uplift the spirit of the users in distress. The VA should be competent and proficient enough to give user a natural human experience by responding empathically and affirmatively. So basically, the virtual agent, the virtual agent's effort is directed towards comforting, allowing the users to share and express their thoughts, moods, feelings, emotions, struggles, and worries. So obviously, the VA should impart optimism, hope, motivation, which are identified as crucial effective factors to uplift the spirit of the users in distress. The VA should be competent and proficient enough to give users a natural human-like experience by responding empathically and affirmatively. So how, first of all, how we created the data set? So we scanned the literature for existing mental health, especially depression related data sets. So there are several data sets like DAICWOZ, text-based counseling conversations, several social media content-based data to study the mental health like Twitter, Reddit, etc. Some of these datasets were purely social media contents of anonymized users containing self-disclosure or self-expressive posts. So basically, you know that we saw that there are many online platforms where user can anonymously register to discuss about their mental issues, and then they can discuss about their mental problems. So we obtained a number of websites like www.samha.gov, askapatient.com, dailystain.org, webmd.com, ginger.io, psychocentral.org, quarter, quatihealth.com, healthrhythms.com. So all these are different platforms where users can anonymously register, and then it can ask a question, and there are many other support seekers. All these support seekers can also provide an answer to the question. So this way, the question can be answered by many other support seekers. So after a thorough research and analysis of all these platforms, we zeroed down to psychocentral.com for further investigation of our problem statement. So, PsychoCentral is an online web based platform for anonymous users to share their state of mind, feeling, and worries and seek help and advice from other users having a similar experience in terms of mood difficulties and grievances. So in the psychocentral.com, already there are many sub forums, and the patient can identify himself or herself as if that he or she is suffering from a particular disease, and accordingly he or she can be a part of a sub forum. So we crawl the web pages of the several subforum to collect conversations of anonymous users. So here we have considered four diseases: mental health diseases, major depressive disorder, anxiety, post-traumatic stress disorder, and the obsessive compulsive disorder. So these are the four disorders that we have considered, and we assume that the patient will consider himself or herself as a part of any of these disorders, and accordingly it will be it will be a part of any of the sub forums. So we scrapped around 10K multi-party conversations. So we crawled some data from each subforum, and we crawled around 10K multi-party conversations. So we identified these four subforums: major depressive disorder, anxiety, post-traumatic stress disorder, and the obsessive compulsive disorder. And then overall, we crawl 10K multi-party conversations. So next, the task was to modify these multi-party conversations into dyadic conversations, because as I mentioned, in this subforum, suppose the one user is asking a question and there are many other users who are generating answers to these questions. So this way it is a multi-party conversations. So our task is to generate make this conversation dyadic. Like there will be one question and there will be one answer. So initially this conversation will be multi-party conversations, but our task is to convert this into dyadic conversations, such that it resembles a motivational dialogue between a support seeker and the VA, imparting suggestion, hope, and the motivation. So we consulted a doctor who is basically practicing in AIMS Patna. So Dr. Pankaj Kumar, who is basically the head of the psychiatrist department of the AIMS Patna, and because we do not have the domain knowledge, so we consulted him, and he basically suggested some annotation guidelines. So how to convert the multi-party conversations into a dyadic conversations, because the data said that we crawled is having the multi-party conversations. So we wanted to convert these multi-party conversations into dyadic conversations. So we need some guidelines. So the guidelines are as follows: that the annotators were So the annotators were asked to create a turn-by-turn exchange of dialogues between the user and the VA from the responses of the poster and the commenter, and make maximum usage of responses from the source conversation to create a dialogue. Yeah, yeah.
Yeah, yeah.
Am I audible?
Audible? Yes, yes, ma'am. Yes, ma'am.
Yeah, so
Yeah, so
these are the guidelines, as I mentioned,
guidelines
given by the
given by the
psychiatrist. So
psychiatrist.
first of all, we have to convert this multi-party conversation into a dyadic conversation. So the annotators were asked to create a turn-by-turn exchange of dialogues between the user and the VA from the responses of the poster and the commenter, and make maximum usage of responses from the source conversation to create a dialogue. And also, as I mentioned, that our task is not to replace the psychiatrist. So a virtual agent strictly cannot impart medical advice, since even if the user is asking for suggestion pertaining to it, seen in the source conversation, as we do not advocate that the virtual agent takes over the task of a mental health professional. So basically, there anyway the virtual agent cannot give any medical suggestions, like it cannot suggest any drug name or any kind of medical advice it cannot give, like regarding the hospitalization or regarding suggesting some drug name, etc. We have removed from the conversation. The messages or responses of the poster were modified to exclude any reference to a group of people as a whole. So, for example, phrases such as "Can anyone tell me?" was converted to "Can you tell me?" Okay. So this way, the messages or the responses of the poster were modified to exclude any reference to a group or people as a whole. And then the VA should always respond in a positive and affirmative manner. So negative utterances from the commenters, such as "I know nothing can change," "we have to struggle throughout," were modified to display optimism, like "life indeed is a struggle for all, but one needs to always fight back and be strong in the face of adversaries." So like this, we have to always impart the optimism, hope, positivity. So this way we have always changed the responses. So our motive dataset is having 7067 dyadic conversations amounting to a total of 25,947 utterances. There are two parties, support seeker and the VA, and we are imparting the appropriate suggestion, hope, and the motivation. And as I mentioned, there are four mental disorders: major depressive disorder, anxiety, post traumatic stress disorder, and obsessive compulsive disorder. These are the four disorder types that we have considered. So here you can see two examples. My 17-year-old son got made and throw something at me. I did not call the police. So my 17-year-old son got made and throw something at me. I did not call the police. I don't want him to go to jail. If you know what I am going through, I would love it. If you would talk to me and help me understand. I feel like such a bad person all of the time. You are not a bad person. You did what you felt was best for you and your son. Don't let what was your husband tell you get to you. Let him know how you feel. It's going to be tough, but it is what needs to be done. Take good care of you. Hugs. And thanks. I have tried telling him. Now I feel I don't know what else to do to let him know that I am just tired of the fighting. Have you tried family therapy? Maybe that might be helpful to get through this. Your family needs to know when to stop. Hope your day gets better. Then, after some time, the VA is saying you should stop doing these things for him. He needs to learn to take care of himself. It's called tap to laugh. We all have to do it at some point and time. Hang it there. So this is one example. Yeah, so basically these are some examples on the motive data set you can see. So finally, this is the statistics of our data set. You can see that there are four diseases: MDD, as OCD, anxiety, and the PTSD. So MDD means that this one, that major depressive disorder, anxiety, post-traumatic stress disorder, and the obsessive compulsive disorder. These are the four diseases that we have. And there are total 7067 dialogues. Number of utterances are 25,947, and number of utterances per dialogue is 3.67. Number of utterances per dialogue is maximum is 129, and number of unique words are 56,336. So this is the motive data set, and one sample is this. I am really struggling to not take more sleeping pills and just pass away out. I want to not wake up for a week. I want to take the easy way out and just sleep away. That's not you talking, Jane. It's the depression. Give yourself some TLC. Do something you love, like long bath with a glass of wine. Go online and play some mind numbering games. Retail therapy. Remember the butterfly game effect. You are here for a reason that you are not allowed to know about. Hugs and keep venting. So then Jenkate say, I double my dose to sleep, but I am still awake and typing fine. Take a little nap, lie down for 10 minutes, shut up your computer now. It's the best thing for you. You won't be able to sleep unless you lie in the dark. Give it a try. Try sleeping, and then my mom tells me we have to go. So I am out and about. I feel fine, maybe a little flowery or light. Tell your mom about the pills so she can keep an eye on you. And please don't do this again. I worry for you. I won't tell her because she will take them away and won't let me take anymore. And I can't just stop suddenly. I will wait for my PDoc and for my doctor and tell him what's been going on. It's very easy to go from 2 to 3 to 4. I recommend the recommended doses is there for a reason, and unless you are a medical professional, you should follow what they say. Then after sometimes BA is saying you need to take responsibility for your thoughts, feelings and behavior. It is not our fault we have this disease. We are not to blame, but we have to be responsible. Own it. Take care of yourself. So this is a sample conversation from the motive data set. So finally, what is the problem statement? So our aim is to solve the task of textual response generation between the user and the VA. So basically, involved in the dialogue along the conversational history. So basically, there is a conversational history, and the user and the basically that conversing, and you have already that user has said something, and now it is the task of the virtual assistant to generate the response. And given the context, and suppose the virtual user has already asked some question, or user has already said something. So now we have to generate the response of the virtual assistant. So this is basically called the natural language generation problem. So the task is to generate the textual response of the virtual assistant given the user utterance and the context of the T turn. So you can consider a window of utterances, previous window of T utterances. So formally given a user utterance, a conversational context or history, the task is to generate the response of the VA. So we used a encoder decoder based model. That we have and we trained this model on the motive dataset that we have just prepared. So basically, as I mentioned, that we considered a context, and we also considered the what user has just now mentioned, and then we encoded the user's utterance. There is a utterance encoder. So we encoded all the previous utterances and also the user's current utterance, and then we given them to the past the classification layer, because there are, as I mentioned, there are two tasks. One is to classify exactly the motive, the mental disorder type, because depending on the mental disorder type there will be different paths to follow. Like if the mental disorder type is depression, then there will be a different path. If it will be anxiety, there will be different path. So there are different paths to follow depending on the mental disorder type. So the first module is the classification task. So basically, we are giving this context and also the user's current utterance, and then there is a classification module. So this classification module is also considering the attentions, cross attention. So because that there is a big context, and depending on the big context, we are putting focus on the important focus on a part of the current utterance, and then we are generating the current mental disorder type, and then that is given as an input to the encoder decoder module, and we inserted different rewards, because our obviously there are some important rewards, like our motivation is not to make the users unhappy in any situation. So our virtual agent should always generate some positive responses. It should never make the user unhappy about the situation, and also its response should be similar to the actual response. So there is a rule score based reward, there is a blue score based reward, there is a sentiment based reward. That way we are training the network. So these are some results that you can see. We have compared with the dialog GPT as well, and these are some confusion matrices. And the diagonals, there are four classes: MDD, anxiety, OCD, and the PTSD, and these are the confusion matrices. So now in the next work, what we have done is that we have also introduced the empathy, because we identified that empathy is also a very important component. Because when the virtual agent in the past component, virtual agent was simply generating some positive responses or was generating some motivational responses. But motivation and the positiveness are important for a motivational dialogue systems, but another important component is the empathy. So if the virtual agent is also empathetic in nature, that is a very important component of a virtual agent. So to the best of our knowledge, this is the first work that seeks to incorporate empathy and motivation together in an end-to-end system for online mental health support. So our end-to-end system employs two submodules in a pipeline manner: motivational response generator and empathetic rewriting framework. So basically, there are two submodules. One submodule is the motivational response generator, so which is very similar to a previous one. Our previous module was also generating some motivational responses, and then that is passed through a empathetic rewriting module. So this empathetic rewriting module is inserting some empathetic components into this, and it is making this part more empathetic. So empathical results indicate that our proposed system outperforms several baselines. So there are four types of empathetic rewritings. One is called the emotional reactions, expressing emotions such as warmth, compassion, and concern experienced by peer supporter after reading seeker's post. A weak communication of emotional reactions alludes of these emotions without the emotions being explicitly labeled. Like everything will be fine. This is a kind of emotional reactions. On the other hand, strong communication specifies the experience emotions, like I feel really sad for you. Then there is this other kind of empathetic reaction. There is another kind of that empathetic rewriting interpretations, communicating and understanding of feelings and experiences inferred from the seeker's post. A weak communication of interpretations contains a mention of the understanding. I understand how you feel. A strong communication specifies the inferred feeling or experience. This must be terrifying or communicates understanding through descriptions of similar experiences. I also have anxiety attacks at times, which makes me really terrified. So there is a weak communication of interpretations contains a mention of the understanding. I understand how you feel. A strong communication specifies the inferred feeling or experience. This must be terrifying or communicates understanding through descriptions of small experiences. I also have anxiety attacks at times, which makes me really terrified. Then there is a explorations, improving understanding of the seeker by exploring the feelings and experiences not stated in the post, showing an active interest in what the seeker is experiencing and feeling, and probing gently is another important aspect of empathy. A weak exploration is generic. What happened? A strong explanation is specific and labels the seeker's experiences and feelings, which the peer supporter wants to explore. Are you feeling alone right now? So what we have done is that there are two modules. One module is generating some motivational responses. So this part is very similar to our previous one. Like there are three reward functions: blue based reward, sentiment based reward, and the do score based reward. So by using this module, this is a encoder, this is a transformer based module. By using this module, we are generating some motivational responses, and then these motivational responses are passed through the empathy rewriter. So this empathy rewriter are changing the empathy part of the sentence. So there are for different reward functions: change in empathy, text fluency, sentence coherence, mutual information. So by using these four rewards, we are changing the empathy part of the sentence. So there are two different submodules. This empathy rewriter, we are not trained. So it is an existing framework partner. It is already trained on a huge amount of data set. So we are only using this network to introduce some empathy into our, into our motivational one. So these are some results that you can see that how we are changing the empathy scores. So use AI to propose a virtual assistant to provide support seekers with comfort and mental health support. As a first step, we create the motive dataset, which contains diary conversations collected from a peer-to-peer support network. So basically, as I mentioned, that there are two components of our network. One is that classification, and then and the first part, after based on the conversation with the chatbot, we are trying to identify the mental disorder type, whether the person is suffering from anxiety or the depression or the that bipolar disorder. So what is the that mental disorder type, because depending on the mental disorder type, different path will follow for the counseling. So there is a classification network. At first there is a classification network. The classification network will try to predict the mental disorder type, and then after that there is a generator network. So this generator network will generate some motivational responses just to boost the morale of the particular patient. So and next at first we generated some motivational and the positive responses, and there afterwards these motivational responses are also passed through some empathic rewriter, and this empathic rewriter are inserting some empathetic rewriting so that it looks more human like responses. Because whenever a human like whenever it is there is a human counseling, counselor or the psychiatrist used to insert some empathy into the generation process. So we surmise that the preliminary step will lead to promising direction for developing computational models to assist peer mental health support seekers. So these are some publications from our from this particular work. So we this the past work where we proposed this classification plus motivational response generation. This work we published in NACL. This is a North American Association for Computational Linguistic. This is a core rank age conference. So the paper says the shoulder to cry on towards a motivational virtual assistant for assessing mental agony. So in this particular paper, we have shown how we develop this motive data set, and then this based on this motive data set, we develop the classification framework, and then we develop this different generation framework. Then the second paper, this towards motivational and empathetic response generation in online mental health support. Here we have developed the not only the motivational responses, but we have also introduced the empathy into the motivational responses. And also initially we started working on developing the data set. So we already developed the depression data set basically, the large scale dataset for motivational dialogue systems. So this dataset is only the depression dataset. So it was not having all the four basically classes. So initially it was we are only focusing on the depression class, and we developed a large scale dataset for the depression category. And we also created some other classification framework, and we published it in the IEEE transactions on computational social assistance, where there is a different type of classification framework for classifying the different mental disorders. So these are the some papers related to mental health. So Tulika Shaha was my PhD student, so she was very much motivated doing some work in the mental health. So she only started working on the mental health. But as I mentioned, it was very challenging because there was no existing data set. So initial years were very challenging. We searched a lot for the data set, but we did not find any data set which can be suitable for building conversational agents. So then we started searching for some sites where we can crawl the data, and then we selected the psychocentral.com is suitable for our purpose, and we crawl the data from psychocentral.com, and we converted this multi-party conversation to two-party conversation. Any question? I think someone has has unmuted. Yeah, Dilip ji. Hello.
Madam, I am Dr. Joel from the Department of Computer Science and Engineering, IIT Bhavalpur, co-coordinator of the STC. It was a very informative presentation, madam. Is there any question, participant, please? I feel no questions. So, thank you very much, madam, for your very informative presentations related to the application of machine learning in healthcare system. Especially, you talked about the multi-model information processing. Particularly, you mentioned that a chatbot applications using a natural language processing. You also presented the concept of virtual doctor to take care about the mental health of the patients using a virtual agent by tracing the emotional reactions. I hope it will encourage our participants to work and explore more research on this topic. Once again, thank you very much, madam, for your beautiful presentations. Thank you, ma'am. So,
Thank you very much for inviting me in this MDP. Thanks a lot.
thanks a lot, madam. Thanks a lot.
Yeah.
So, I feel tomorrow will continue with as per schedule. Thank you to all participants. Thank you.